in an experiment.
And we don't know yet.
Why is light so far?
Like, it sounds so simple.
They had no idea.
But now the data speaks.
I find this not only refreshing, but at some level astounding.
Nature.
Welcome back to the Nature Podcast. This time, the stereotypes lurking in images on the internet,
astronomers' favourite exoplanets,
and the 2025 Nobel Prizes. I'm Benjamin Thompson.
And I'm Nick Perchichow.
The internet. It's an invention that helped propel humanity into the 21st century. Now we can get research papers, the award-winning Nature podcast, and videos of pandas falling over at the touch of a button. It shapes the way we now live our lives. My job would certainly be a lot harder if I didn't have it. But how is the internet shaping us? Well, a new study in Nature has trawled through images of people on the internet from Google searches, Wikipedia, and movie databases, and found some underlying stereotypes. They saw that generally women in these images tend to be younger than men. When looking at images related to jobs, it seems that some roles are more associated with older men and others with younger women, even if that doesn't actually reflect the underlying reality. And these stereotypes don't just exist in images on the internet. Those images may in turn be shaping how we see the world and how we view who can do which jobs. Not only that, but these biases have gotten into our AI chatbots and could affect who is hired in the future. Reporter Shamini Bundell caught up with study author Douglas Guilbeault from the Stanford Graduate School of Business to dig into the details. Douglas and the team looked at images from various places across the web, and one of them was the Internet Movie Database, or IMDb, and Shamini asked what they were looking for here.
One of the things that was convenient from the research point of view of IMDb is that we can link it to biographical profiles of celebrities on IMDb or Wikipedia. We can get their actual age and their self-identified gender. And crucially, we could also see the timestamp of when the image was taken that's put on IMDb. So we actually know exactly how old they were in that image at that time. And what we found, of course, was that women were many years younger on average than men on IMDb. The implication of that is these are people who are influential. These are the idols. These are the celebrities. These are the people who inspire people to pursue careers, to get engrossed in their stories and learn life lessons from their films and so forth. And so seeing this age distribution in such an impactful population of people is extra concerning from the point of view of the possible consequences of these stereotypes.
Obviously, the entertainment industry is not necessarily a bastion of gender and age equality. You know, maybe it's just the celebs, maybe it's just the famous faces, but you wanted to look more broadly at different social categories. So you looked into Google image search results.
We looked at a comprehensive set of what we call social categories, which includes occupations, so like banker, doctor, carpenter, baker, but also everyday social relationships like friend, colleague, and neighbor. And what's important about those everyday categories is they're often in no way directly gendered, right? Like a neighbor can be a man or a woman, a colleague can be a man or a woman, right? But what we see is even when we collect images for these everyday social categories from Google, these biases are very much present. And so we see even in these categories like neighbor or friend, women are still appearing as younger than men.
You've collected a load of data from Google Images. So that's, you know, searching Google Images for these words, friend, baker. Were you manually just downloading loads and loads of photos and just was someone just sat there doing Googling?
I think my hair would have grayed if that was the case. Thankfully, we were able to automate that part of the process. So essentially, we scraped these images.
And then you got volunteers to look at them and essentially guess roughly how old they thought the people were.
Yeah, we hired thousands of people online to classify the age and the gender in these images.
What kind of things do you tend to see?
So if you say search for an image of a doctor or an athlete, what you'll get are a combination of images of prominent doctors or athletes, so actual folks. You'll also get images of sort of fictionalized representations, so like stock photos or the kinds of images you see on corporate websites for advertisements. And so what we tend to see, and this is what's particularly striking, is that in all these different cases, these different sources of images, consistently the women in these categories are appearing systematically younger than men.
So your job is being an assistant professor.
Yeah.
Do you think if you Google assistant professor, do you think you look like what the internet thinks an assistant professor should look like?
In some ways, no. I can say, like, personally, when I go to the cafeteria here, they often ask me if I'm a student. Maybe it's my inability to grow a full beard. I can grow a mustache. I don't know if the world wants that. But so maybe I'm a bit of an outlier. But I will say, though, that there is a sort of stereotypical image of what a professor looks like. And of course, this can vary, but the sort of archetypal image is an old white guy with a corncob pipe and pads on his sleeves, right? But in that is actually an age idea, right? And perhaps we're not used to thinking that way, but there is a sort of sage on the stage kind of attitude around professors where you have this sort of like old, wise man, essentially. And that's changed a lot. It does not at all reflect the actual distribution of professors today, but it was historically the case that it was older men, and there's still a legacy of that stereotype impacting our understanding of what it means to be a professor.
And can you give me some examples of the extremes then, the most sort of old and male occupations and the most sort of young and female ones? What kind of things are we talking about?
Yeah, absolutely. So for men that are in older ages, you have like chairman of the board, chief of staff, director of research, chief technology officer. For women, you have cook, secretary, intern, even nurse. And so you see the more female coded categories tend to be those that don't actually have a clear age requirement or age expectation. If anything, it's expected that they're younger.
And for some of these, that's presumably not true. Are all nurses younger than all doctors?
Yeah, in fact, I think that's one of the most striking aspects of our study is we then look at US Census data on occupations and industries. And what we find is actually, especially in the last decade or so, there is no real age gap between men and women. So most of these occupations, women and men are either the same age on average, or even women are older. Basically, any time that an industry, say maybe it was sales or management in a particular year, if it showed that in the actual census data, women were older than men, the internet told us the opposite. The internet said for women in those industries, they're actually younger than men, and the men are older.
You also looked at how the internet then is influencing us in turn, and what we see is actually changing our opinions, even our beliefs.
Yeah, and so what you start to get is what in sociology we call a self-fulfilling prophecy, right? Which is if the stereotypes are sort of what we think the world should be like, then we interact with the internet and we start to increasingly believe that our idea of what the world should look like is actually what the world looks like. So in this experiment, people were tasked with searching for images online. And then what we had them do was download an image that they think is a good description of a doctor. We could see, did they actually choose an image of a man or a woman? And what we see is that people actually have this bias towards assuming that jobs that are more associated with women are associated with younger ages. So we already see this gendered ageism pattern in people's responses. But then we look at what happens in the condition where they're actually exposed to images of the occupations. And what we see is that age bias is intensified. So it has become worse just from them viewing images of occupation online.
When you were sort of looking at internet data, a lot of what you were looking at was training data for large language models, AI of different types. And in particular, you did a bit of an experiment with ChatGPT. Tell me about that.
So the part of our study of ChatGPT that was geared towards understanding the real world consequences was studying how it evaluated resumes. And this is a very common use of ChatGPT today in organizations. People use it to score resumes and then rank them in terms of which resumes have the top, say, 10% or 5% of scores. And then they only focus on their future hiring processes on those top ranked resumes. And so what we did is we had ChatGPT evaluate resumes from men and women, and we could control for things like how much experience is reported in this and so forth. And what we find is that it systematically gives higher scores, first of all, to older applicants. So it really likes when applicants are older, perhaps because it conveys expertise. It also likes, of course, when resumes have more experience. But what we found is controlling for all these available features, it systematically also just preferred older men to younger women.
And we've talked about so many different elements of this stereotype. What would you want people to take away from this research?
We really don't represent our social world accurately. That even something seemingly simple like the gender and age of an occupation, we actually have a kind of mythology around this. And this is concerning because the AI revolution and these large language models rely on learning from all of this data that humans produce. And so what we're doing is creating a system where it's basically learning from our stereotypes and our mythologies about how the social world works. And what we can see is that it's already perpetuating biases in its hiring preferences, its evaluation of candidates. And this is really just the tip of the iceberg. And so it really raises this question of how can we design tools and build culture in a way that actually helps us better calibrate our model of who we are, what society is, that can actually eliminate some of these biases, not just for our own behaviors and beliefs, but increasingly so that the AI systems that are gaining ever more power can actually also build an accurate model of the world and stop perpetuating and reinforcing these biases, and can maybe even help us embody the better angels of our nature.
That was Douglas Guilbeault from the Stanford Graduate School of Business in the US, speaking with Shamini Bundell. For more on that story, check out the show notes for some links.
As is traditional around these parts, we'll be rounding up the winners of this year's Science Nobel Prizes. Stick around for that. Right now, though, it's time for the research highlights with Dan Fox.
Astronomers have identified a very hungry exoplanet that's gobbling up gas and dust at a rate of 6 billion tons per second. Young planets grow by accumulating matter from a disk of material swirling around them. But researchers studying the planet CHAR 11077626 saw that its appetite varied over time, with the amount of material it sucked up from its surrounding disk changing. Starting in June 2025, it ramped up its accretion rate by as much as 8-fold to the highest rates ever measured for any planet. Growth spurts like this also happen in young stars. Understanding these changes could reveal more about how young stars and young planets interact with their surroundings, and how those changes affect how they evolve with time. Devour that research in the Astrophysical Journal Letters. Trees in the Amazon are larger than they were a decade ago. Climate change is reshaping forests around the globe, and while droughts and wildfires are killing trees, higher levels of CO2 can act like plant fertilizer in the air. And unharvested parts of the Amazon rainforest have been steadily gaining biomass over the years. So researchers looked at how the size and structure of trees in 188 mature forest plots, ones that have been generally less disturbed, around the Amazon rainforest have changed over 30 years. They saw that trees in these plots grew thicker over time, with the average size of their trunks at chest height gaining around 3.3% each decade. Larger trees also grew faster than smaller trees did, and are now more common than they once were. The findings suggest that the mature Amazon rainforest has, so far, avoided the worst impacts of climate change, although the authors caution that the incidence of threats like drought and lightning strikes are still expected to increase. You can find that paper in Nature Plants.
On Monday, the 6th of October, it was the 30th anniversary of when astronomers announced they'd found the first exoplanet around a sun-like star. Since that momentous discovery, astronomers have been busy spotting more and more of these planets from beyond our solar system, and now they've found more than 6,000 and hints of many thousands more. So to celebrate these 30 years of astronomical analysis, I'm joined by Alex Whitsey, who's been asking astronomers a very important question. Which exoplanet is their favourite? Alex, hi, how's it going?
Good, good. How are you doing today?
I'm good, thank you, and I'm excited to learn a little bit more about astronomers' favourite exoplanets. I guess let's start with planets that are very close to us, or at least relatively close to us, as it seems that those planets topped a lot of astronomers' lists.
Yes, we're talking about Proxima Centauri here, the closest star to the sun. You know, we wanted to do this story about 30 years of exoplanets by asking astronomers which were their favorites, as you said. And almost everybody wrote back, they're like, you already have Proxima Centauri on the list, right? Like, you don't need me to say Proxima, do you? So I'm like, no, that's fine. Give me another planet. But yeah, everyone loves Proxima because it's so close. It's just 4 light years away. And back in 2016, astronomers found the first planets orbiting it. So we know there's 2, possibly 3. These worlds are probably small. And there's been a lot of dreams about could we go visit these worlds because they're so close. There's this effort called Breakthrough Starshot, which is supposed to send fleets of little tiny weeny solar sails the 4 light years across to this world. That project hasn't gotten very far because of the technological difficulties involved. But basically, the Proxima planets are the worlds that people dream about when they dream about interstellar travel to other solar systems, because they are so close.
Yeah, I guess if we're going to go anywhere, it would probably be there.
Yes. Maybe not tomorrow, but later this century, one astronomer told me.
Well, I can't wait for that if I'm still around at that point. But I wanted to talk to you next about the exoplanets orbiting TRAPPIST-1. What made these stand out to astronomers?
Yeah, so this was second on everybody's list. They said, oh, you've got Proxima already. You've already probably got TRAPPIST. So let me try and think of something more unique. So the TRAPPIST-1 worlds are wild because you have 7 Earth-sized planets kind of lined up all in a row, like peas in a pod is kind of how people talk about them. You know, many of these other solar systems are like 1 or 2 planets, maybe kind of big, maybe kind of small, maybe far away from their star, maybe close. The TRAPPIST-1 planets are like 7 Earths basically lined up in a row. And several of them are in the habitable zone of their star. That's the distance at which liquid water could exist on the surface, and therefore, in theory, life could exist because life requires water. So these are 7 worlds, all at different distances, all with chances for life to evolve. So people are trying to study these worlds to see if any of them have atmospheres, which again might imply that there's life or something on them. But essentially, it's a laboratory for testing out theories of what might happen if you have an Earth-like planet around another star.
And one of the quotes from this article stood out to me from Nestor Espinosa about how you could probably see these planets like moons in the sky, which sounds very cool.
Yeah, Nestor's been using the James Webb Space Telescope with his team to look at some of these planets. And so he's been envisioning what it's like to stand on a surface. So just imagine looking up, very sci-fi. You know, we've got 1 moon in our night sky. Imagine having like 6 moon-like things studying across.
Very cool. Then moving on, we've got a musical system, I want to say, K2-138. What can you tell me about this one?
Yeah, so this system is similar to many others in that it has these orbital resonances. So what that means is as the planets move around their star, they move in patterns. In this system, for instance, some of the planets move around their star 3 times at the same time that it takes the more outermost planets to go around twice. That's called an orbital resonance, and planets can kind of fall into that pattern as they move around over time, as their orbits are disrupted, as their gravitational influence kind of affects one another. And it's very unique and interesting to have these orbital resonances. We have some versions in our solar system and nothing cool like this. And on K2-138, these resonances are 3 to 2. So 3 orbits at the same time it takes other planets for 2 orbits. And so astronomers like to turn things into music, and this is like a perfect 5th interval in music.
And yeah, listeners, I recommend checking this one out. I'll link to it in the show notes so you can have a listen. And it's not just that this system has this sort of musical quality to it. It could give us clues about how planetary systems form, right?
Yes. So again, because this system is so very different from our own solar system, it tells us kind of all the varying conditions of how these systems can come to be. Again, in a lot of systems, planets kind of jostle each other around. There's sort of violent chaos and collisions as the planets are forming around their star, billions of years ago or whenever that happened. And a lot of times planets get jostled into weird orbits and thrown out and do weird things. This system is kind of calm and collected. An astronomer I talked to said that everything sort of has settled into this musical resonance very gradually and gently. So it kind of preserves these rare clues to how systems can form, how planetary systems can form, because it hasn't been jostled up like all these billiard balls. So they're looking at, where are the planets? What are their densities? How did they get there? And it's a rare way to look at that because it hasn't been all messed up.
And then 4th on many astronomers' lists, there's the planets around TOI 178. What made these exoplanets so special?
This is a really cool system because it's very, very closely packed. So if you think about our solar system, Mercury, Venus, Earth, Mars, and all that, think about Mercury, which is the closest to the sun. Now imagine if you had 6 planets inside the orbit of Mercury. So 6 really jammed up against their star. I mean, that's kind of crazy, right? They're so incredibly close. And as a result, they're just a really unique system. So theory had predicted that we could have systems like this. But when astronomers found it, it confirmed that, yeah, there are ways in which you can cram all these planets really close to their star. And I will say that the person who nominated this system did it too, because he was involved in the telescope that helped confirm this. One of kind of the through-running stories of planetary discovery is it takes a lot of tools to find these things. Ground-based telescopes, space-based telescopes. In this case, a NASA mission kind of hinted that there might be planets here, and then a European Space Agency mission was able to confirm and say, yeah, wow, there's like 6 of them packed in there really tightly.
And then finally, last but not least, there's a star system that's perhaps a little bit reminiscent of a sci-fi movie that I'm sure people will be familiar with. This is Kepler-47.
Yes, and I have a soft spot for these planets. These are the circumbinaries, right? So a lot of stars in the galaxy are single, like our sun, but many more are binary. So there's 2 stars kind of orbiting one another. You would think it's not a very stable configuration for a planet to form around, because how do you orbit 2 stars, right? But theory has predicted that you can actually get these things forming. And Kepler-47 is an example of one of these circumbinary planets. Now, yeah, the world you're thinking of is, so Star Wars, of course, the desert planet Tatooine has 2 suns in the sky. So if you were living on one of the planets at Kepler-47, you would see twin suns as well, too. So we've got worlds where you can see other planets. We've got worlds where you can see twin suns. This is very, very sci-fi. And Kepler-47 is, yeah, a rare example of one of these circumbinary systems. How they form, it's a little bit wild, but it shows once again that there's just like more worlds, more diversity, more ways to make other things out there than we certainly had thought 30 years ago.
And I have to ask as well, do you have a favourite exoplanet?
I do. And because here we are at 30 years, I have to say it's the 30 years one. So 51 Pegasi b is the one that was announced 30 years ago. That's kind of a hot Jupiter, one of these big gas giants orbiting close to its star. And it was announced 30 years ago by the Swiss astronomers. They made this announcement at a conference in Florence and later published it in Nature. It was a big famous paper in Nature that gets a lot of citations. And the astronomers won the Nobel Prize in 2019 for discovering it. But the reason it's my favorite planet is, as a journalist, I always like the first, right? And I was involved in covering a little bit. There were some discoveries in the early 90s of planets around a dead star, pulsar. And so in 1995, when these astronomers announced 51 Pegasi b, it was the first world around a star like the sun. And I just remember the excitement in the newsroom, and everybody wanted to get their hands on the paper and who was going to be at the conference in Florence and confirm what they were saying, because it flew a little bit under the radar at first. It was not clear immediately that this was going to be such a consequential thing. And it took a couple of weeks kind of for it to sink in how significant this discovery was. And by the time the Nature paper came out, everyone was like, yeah, this is a big deal.
Thanks so much for joining me, Alex.
Thanks for having me.
That was reporter Alex Whitsey. For more on that story, check out the show notes for some links.
It's Nobel's week this week, and Flora Graham, senior editor of the Nature Briefing, joins me to chat about the winners. Flora, thank you so much for being here.
It's the most wonderful week of the year.
It's our 6th year doing this, and it's the 6th year that you and I have been cruelly overlooked once again for a Nobel Prize.
Well, Peace Prize hasn't been awarded yet.
Well,
so.
This is true at time of recording. Well, let's talk about the science prizes, and let's rattle through the winners. On Monday, we had the Nobel Prize in Physiology or Medicine, which was shared by 3 scientists, Mary Bronco, Fred Ramsdell, and Shimon Sakaguchi.
That's right. They discovered a new class of immune cells. This was a mystery. How do our immune cells attack invaders, but not our own tissues and systems? Well, it's thanks to what is now called regulatory T cells. They provide a brake on the immune system, and they keep us from developing autoimmune conditions.
I'm right, and these are a very small population of our kind of total immune system, and folk guessed that there must be something, but what it was a mystery for a very, very long time until Sakaguchi stepped up in the early 90s.
Right, and in 2001, Bronco and Ramsdell discovered a mutation in the gene FOXP3 that caused fatal autoimmune disease in mice, and they showed that mutations in the human equivalent of this gene caused a rare genetic autoimmune disease. Then in 2003, follow-up studies by Sakaguchi again and his colleagues showed that FOXP3 is specifically expressed in these regulatory T cells, and it's required for their development. So studies have now found that people with some autoimmune disorders, we're talking about type 1 diabetes, lupus, rheumatoid arthritis, multiple sclerosis, they often have too few regulatory T cells in their blood, or ones that don't function properly.
And as we've discussed on the podcast many, many times, the human immune system is a fascinating thing and a fantastically complicated thing as well. So it took a long time to get to this situation where these regulatory T cells were identified and what their function was better understood. And this has led to a lot of interest from pharmaceutical companies.
As you can imagine, there's huge amounts of interest in these cells and what they could mean for treating autoimmune diseases, which I think we can say are some of the trickiest problems in medical science right now. And a lot of pharmaceutical companies are investing in research into how regulatory T cells can be used as a therapy, whether to treat type 1 diabetes, autoimmune hepatitis, or even to suppress rejection in transplants.
And one thing we love to do, Flora, is talk about the reactions of the winners. And for this prize, there is some absolute gold. Sakaguchi in the press conference was asked how he's going to celebrate, and he said he was going to have a hot bath and a good night's sleep.
Having been to Japan a couple of times, the hot bath in Japan is not to be delayed, not even for your Nobel Prize.
Well, Bronco said she thought the call from Sweden in the middle of the night was spam, so just rejected the call.
Well, a big discussion here at Nature, would you leave your phone on Nobel's Eve? Or would that be kind of too bold? I think you'd have to have a pretty secure sense of self to think, I might get the call tonight. I think most of us would probably do what she did.
Well, someone who definitely didn't have their phone on was Ramsdell, who only found out, I think it was 24 hours later, because he was out with his wife in the wilderness hiking and camping, and the phone was in aeroplane mode, and they eventually got hold of him and was delighted, understandably.
Oh, this is just the best quote. Apparently they phoned up, this is quoted in The Guardian, they phoned up Ramsdell's lab, and they say a spokesperson, now I can only imagine some PhD student who picked up the phone, who said, quote, he's living his best life off the grid, which I just think, that is life goals for any of us, really, and good for him for keeping that work-life balance that we all aspire to.
Well, let's move on to Tuesday and the Nobel Prize in Physics, and that was awarded to John Clark, Michel Devoret, and John Martinez, who demonstrated quantum tunneling at a macroscopic scale.
Yes, this is really notable because we're talking about quantum mechanics. This is the physics of the tiniest scales that we know, demonstrated in big world, the world where classical physics reigns supreme. So quantum tunneling specifically is the idea that because of the probabilistic nature of quantum mechanics, quantum objects can kind of leap from state to state, tunneling through maybe energetic barriers and things like that, that should, from a classical sense, make those changes impossible. In this case, what the team did, and they were all working together at the time in the 80s, is they built a tiny little circuit, which we call a Josephson's junction. It's made of superconductors. So this is where current can flow without any resistance. And these circuits were tiny, but still very, very much outside of what we would typically consider the quantum realm. And what they did is they very, very, very carefully turned up the current, and they were able to detect this leap between states, which is a clear sign of quantum tunneling. Now, we had no doubt from the theory that quantum mechanics is absolutely valid at every scale, but to actually complete an experiment that explicitly showed that happening was considered a massive breakthrough and really has had huge repercussions through all kinds of technology since then.
Right, because quantum tunneling explains things at an atomic level, like radioactive decay and what have you, but there was this gap, I suppose, and this step to show that it could be expanded into something you could actually see was important. And this really seems to be a key step in the ongoing development of quantum computers.
Exactly. I mean, these superconducting electrical circuits are used in a lot of applications, but quantum computers right now is one that everyone seemed very excited about at the Nobel announcement. You know, these are computers that are potentially going to be able to do calculations that classical computers just can't do.
And what did the winners make of the announcement then?
Well, I think at the announcement, they only had John Clark on the phone. And, you know, what I really noted from what he said and what comes in loud and clear every year is he made constant reference to the fact that this is a team effort, that we stand on the shoulders of giants, that his achievement is, yes, it's the foundation of so much of the technology that we use every day, but actually he just mentioned over and over again that, you know, one thing people complain about a lot about the Nobels is they fall into this trap that one person or two or three can take the credit for these great advances and breakthroughs. But over and over, what the winners themselves say is, I was part of a huge team. And I think that that is just so delightful and so important that we recognize that this is how they themselves perceive the prize.
Indeed. And let's move on to the final of the science prizes then. It was announced this morning as we're recording this. And this is, of course, the Nobel Prize in Chemistry. And Flora, this is a story that is full of holes.
That's right. This year's winners developed the most porous materials in the world. We call them metal organic frameworks, or to their friends, they're called MOFs. These are super sponges. So they have enormous interior surface area, and you can store a huge amount of stuff, whether liquid or gas, inside. So we're talking about the TARDIS from Doctor Who. They're bigger on the inside.
And let's talk about the winners then. So this is Susumu Kitagawa, Omar Yagi, and Richard Robson.
Right, and the MOF concept was first developed by Robson in the 1980s. He was inspired by the structure of diamond crystals, and he made this material out of pyramidal-shaped molecules with metal atoms linked by organic molecules. Then in the early 1990s, Kitagawa developed MOFs that could be filled with water, and they wouldn't be disrupted if they dried out. So this is this idea that not only can you put stuff in, you can also take stuff out, which is really important. And Kitagawa also realized that MOFs could change shape depending on whether they were filled or not. And around the same time, Yagi was developing ways to make these MOFs more stable, and he worked on a way to make the linkers in them longer. So we have the most extreme examples of MOFs. The record breakers are ones where you've got the surface area the size of a football field in a gram of material. That's like the size of a sugar cube.
Which is very much where the TARDIS comes in. And this is one of those prizes that I think a lot of people were saying they're going to win at some point for this. And there's potentially a lot of translational aspects to this work.
Yeah, there's a lot of enthusiasm for MOFs. Research chemists have made hundreds of thousands of versions of these materials. And it's thought that they could do all sorts of things, from pulling carbon dioxide from the air to maybe cleaning toxic forever chemicals from water. So there's lots of interest and there's lots of progress, but it is very much preliminary at this stage.
Well, wonderful. Flora, thank you so much. as ever, for joining me. I hope you'll join me again next year for our 7th go at this. And hey, maybe it's our time.
Fingers crossed.
And listeners, for all of Nature's coverage of this year's Nobels, head over to the show notes for some links.
And that brings this week's episode to a close. If you've enjoyed it, why not let us know? You can leave a review or comment on your podcast app of choice. You can reach out to us on X or Blue Sky @Nature Podcast, or you can send us an email to podcast@nature.com.
In fact, if you are reaching out to us and you feel that way inclined, you could drop us some birthday wishes, because listeners, this week marks the 20th anniversary of the Nature Podcast. Thank you to everyone who's ever taken part in the show, and to you, most importantly, for taking the time to listen. Here's to the next 20 years. I'm Benjamin Thompson.
And I'm Nick Petrichel. Thanks for listening.